Today, what we're going to be covering is the result of a hack day that we did back in December. We spent a day and a half playing around with LLMs and seeing how we might integrate them with our product Cantabular. Before we get started on that, we're going to do a quick introduction to Cantabular because it's kind of foundational knowledge that we need for everything else to make sense. We'll also explain briefly what LLMs are. You probably know, but I think it's good to have a kind of shared understanding, so we'll go through that too. We'll then talk about, very briefly, some LLM use cases for statistical offices or agencies. Then we'll cover the demos from our hack day. That'll be my colleagues, Peter, Duncan, and Spencer presenting. And then we'll have a final summary and some questions, time for questions at the end. So a very quick introduction to our software Cantabular. So what is it? Well, it helps organizations deliver more data faster with automated data publishing. So the key thing is that it allows statistical outputs to be produced directly from microdata with disclosure checks applied in real time and along with integrated metadata. So best way of understanding it really is to see the products that it's enabled. So back in March of last year, the ONS launched this new product, Create a Custom Data Set, which allows users to build tables of 2021 census data, arbitrary tables. They can make their own choices of what variables to include. And similarly, NISRA, the Northern Ireland Statistical Research Agency, published a flexible table builder, also using our software, but in this case, using our user interface as well. And this allows a user of the Northern Ireland census to build their own table direct from the microdata. So they're both powered by Cantabular. You can build your own cross-tabulation, as I've said, created in real time from microdata. There are automated disclosure checks that kind of enable that to happen. This means there's hundreds of millions of possible tables available from the census, previously maybe only thousands. So the value of the census to society is much greater as a result. The metadata for a table is pieced together when it's built on demand. And in fact, all outputs are generated on demand. So whether that's an Excel file or a CSV, it's all created at the point at which the user asks for it. And the big benefit of that is that if you have a change in your data or in your metadata, it kind of propagates all the way through the system straight away. You don't need to go through and correct a million outputs. And as Jen Wolford from the ONS said, it allows us to release billions of statistics far more quickly than ever before. She said it far better than any of us could have said it. So moving on, what are large language models? So I thought maybe a good way of figuring this out was to ask ChatGPT. You've probably all used ChatGPT. If you haven't used it, I'm sure you've heard of it. This is a very long explanation, so I've picked out just a chunk from it. So LLMs are advanced natural language processing models, and they understand and generate human-like text. They're using deep learning techniques, and they're trained on massive amounts of text data. So another way of thinking about them is they're a function. So they take text as their input, which we also call a prompt. It's often called a prompt, but it is just text. The LLM then does its job really is to predict the text that comes next. And that's what they're doing. That's all that they're doing. But they're very complicated in the middle, but that is their function. But it's also important to know that it's not a deterministic function, it's a probabilistic function. So if you give it the same text, the same input, then you might get a different output the next time you try it. As an example of this, I have a program installed on my computer called LLM. It's just a little helpful Python library that makes it easy to use different open source large language models. And here I'm running that program. I'm telling it to use this particular language model that I have installed on my computer, and I'm giving it this input. So in the previous diagram, this text here, the capital of England is my input to the model. And then the model is coming back with this output of London. So that's fairly straightforward. Seems like it's doing a good job. But the interesting thing about these, a very interesting thing about these LLMs is that we can get them to behave in more complex ways by giving them a more kind of nuanced prompt. So here, what I'm doing is I've got the same input text, but I'm kind of wrapping that input text in a prompt, in what's called a system prompt. And that's saying that's sort of adding this extra context. So you are an AI assistant. Human says capital of England is, and then the assistant says, and now we have different behavior from the model. The model is now replying, the capital of England is London. So it's kind of giving a fuller response, which is sort of makes sense in the context of being an assistant. So what we're doing here is we're kind of enlisting the LLM into a little play where it takes the role of a helpful assistant. And we can use similar tricks to get LLMs to do other things. So we can ask it to think logically in steps, or to choose between a set of actions, or to write in the style of Shakespeare. And using these different prompts, we can get them to behave in more complex ways. And then that behavior can be systematized and harnessed in different ways. And that's kind of what we're going to see today in our demos, different ways of harnessing the behavior of LLMs. And if you're interested in learning more about them, maybe you already know a lot, but if you don't, then I can recommend these places to start. So the first is a blog post of a talk by a guy called Simon Willison, who's written a lot about using LLMs in practice in applications. The second is a video by Andre Karpathy, who's an engineer at OpenAI, and he's produced a lot of very helpful content about how LLMs work at a very detailed level. And then finally, there's this interesting paper from the UN Economic Commission for Europe looking at large language models for official statistics specifically. So we're just going to discuss that now, actually. So how might a national statistical office or other kind of statistical agency use LLMs? So I think the first example, and it's kind of a sort of an obvious thing now, and something that if you're writing code and you're not already using them, then you probably should be thinking about it. So on our technical team, our developers, we all use something called GitHub Copilot. That makes it very easy for us to it sort of makes it more efficient to write code. If we're in the middle of writing something, it will suggest a completion that we might want to accept. And it just makes it more efficient to write code. It's also very useful when you're translating from one language to another, or if you're writing code in a new language that you're less familiar with. The second use case here is natural language search. So another kind of concept in the world of large language models is something called vectors. And basically, you can use these to improve search across any kind of corpus of knowledge. So you can take a description of something. So it might be a data set on your website. It might be a variable in your data dictionary. And you can give it to a large language model and say, what does this mean to you? And it will come back and say, here is a big list of numbers that represents what that content means to me. And you can get that you can do that query and store those what are called embeddings for a range of stuff on your website. Then when a user comes to do a search, you can take the user's query, give that to the large language model and say, what does this mean to you? And then you can kind of do a comparison against the user's query and all these stored embeddings and say, which of these things is most like what the user is looking for? And that turns out to be really quite a good way of doing search using this sort of the learned behavior of these models. And there's a good example of that. The ONS did a blog post about a proof of concept around this. The third use case is about automatic generation of summaries and reports. So LLMs are very good at generating text. So it seems like a logical thing to do. Well, maybe it can help us write reports. And Statistics Canada have done an example use case of that, which is in the UN ECE report that I linked earlier. And also one of my colleagues, Duncan, his presentation will be about this exact thing shortly. And then finally, the last use case is around using LLMs to create queries to data sets so that you can say, well, I'm looking for this data, do you have it? And then the LLM will kind of understand the user's intent, go off, do a query of a database in some way, and bring back the data. And we've got 2 demos along these lines imminently. And also the IMF use case or case study in the UNEC report covers this too. So that's a very quick run through of some use cases that are relevant to statistical agencies. So moving on to our hack day, what we were trying to do was just spend a little bit of time to learn firsthand about how we could use LLMs in practice. And that will make it easier for us to spot opportunities to use them in our work. A big learning from this for us was that it's really easy to get something running, but it's really hard to engineer a reliable product. And this, to an extent, goes back to what I was saying earlier about them being probabilistic in nature. And normally when you're engineering software, you can rely on, you give it a particular input, you always get back the same output, and that means you can test the system. But that's not the case with LLMs, so you have to take completely different approaches. And the kind of the world of the ecosystem of tools and techniques around LLMs is evolving very, very rapidly, and people are learning very quickly about how to do this better. Before we get onto the demos, one thing to say is that our software Cantabular is kind of in the background of all of them, in that they are all talking to it through our API. Cantabular is running for the Northern Ireland census, and all the example applications you're about to see are actually using the live data from the Northern Ireland census via Cantabular. So with that all said, I'm going to pass over to my colleague, Duncan Harris, who's going to talk about generating geographic area summaries.
Hi, yes. My use case was to think about a scenario where we might want to provide some kind of indication of what the main story was from the census for a particular geographic area, or something along those lines. Obviously, it was only a quick prototype, so we got a certain way into that storyline. To set a sort of intermediate goal, we wanted to create a textual summary for a geographic area, maybe highlighting the distinctive characteristics of that area. So how do we go about this? What we're going to have to do is fetch some data from Cantabular and then ultimately format that somehow that's a suitable input for the large language model. In order to provide some kind of context for the large language model to establish what's distinctive about a particular area, what we're going to do is compare the area to its surrounding areas. So in the census data, we have a geographic hierarchy, and what we can do is if the user asks for any particular area, we can look at what kind of area type that is. We can look at what the parent area type is in the hierarchy, and then we can find its parent area and so forth up the hierarchy. In the NISRA data, which we're using for our projects, then there's only about 3 levels of hierarchy. So it's a fairly nice example where you can constrain the amount that you're going to give to the LLM. So the first step is to find the area that the user's asked for via some search mechanism, and then the user having chosen the area, we look at the parent area from the Cantabular data, and then we look at also the whole population. We do a query to Cantabular for each 3 of these areas, which is a relatively quick process. And then once we've got the data out, we need to kind of normalize it so that they're easily comparable. It helps if there's work that can be done that is easier to do outside the LLM, then it's much better to do it outside the LLM. And this is an example where we're going to convert all the data into kind of percentages of the table total rather than using absolute numbers. That makes it easier to compare areas of different population sizes and easier for the LLM to do that. Then we generate an LLM prompt, which is the text that we're going to feed to the LLM, which contains some preamble, which also explains about the area types and the areas we're looking at, and then the actual data for those areas. And then having done that, the prompt also instructs the LLM as to what text you would like it to generate as the completion. So if we and then we take that, format it if necessary, and pass it back to the user. The prototype used fixed variables. We could, in principle, look at various ways of establishing which variables we might be interested in by looking for most significant changes. And this is an example where these kind of vector databases might come in useful as well, which are something that's gained prominence with the AI systems. So you can look at, for example, the difference between 2 tables and work out how similar they are using a vector database. So an example of the kind of prompt that we might have generated for this project, which is a real example from the code, where I've elided some parts of it so it'll fit on the slide. We give it some preamble, which does include things about the area types, the actual areas we're talking about. And what's interesting here is that it works much better if you actually talk in English to the LLM rather than trying to give it structured data. So as far as possible, you should talk in English as though you were talking to a human, rather than kind of formatting data in a kind of structured bullet points or tables or something like that. So we actually are quite verbose, if you like, and that tends to give better results. So the example output from this this particular prompt is this sort of text that comes back. Now you can easily steer this text if you want. So in this example, it's quoting numbers from the tables, and it also does unprompted addition. So the bottom where it says 10.02% in total, it's actually picked two numbers out of the table and added them together, even though we didn't ask it to do that at all. If you don't want it to quote numbers from the table, then you can ask it not to do so, and it won't. There does seem to be some risk that if you're getting it to quote numbers, that it may not always quote the number exactly correctly, and this would be a sort of example of the kind of hallucination problem that is widely referred to with LLMs. I never saw it doing that with GPT-4, but if you want to remove that possibility, it's fairly easy to do so. And so it is tunable. So the learnings from this are use English to talk to the LLM. An example is like using text like Belfast, which is a local government district, gives much better results than a kind of structured form of local government district : Belfast. It often misconstrues the latter and doesn't really understand that one is a type and the other is a place name. The using a system prompt, as Mike alluded to in his intro, is helpful, and that GPT-4 will do unprompted calculations unless you tell it not to do so. So with that, I'll pass on to our next use case.
Hi, so for my use case, I thought, wouldn't it be nice if a policymaker wanted some data for the census data, if instead of trawling through different websites and spreadsheets, they could just go to one central location and ask for the data in natural language, and then the data would just appear in front of them. So with that in mind, I set about seeing how far I could get in a couple of days to generating a natural language interface for the Northern Ireland Census 2021 data. And with that, I'm going to take control of the presentation and show you how far I actually got. So I ended up with a web application that lets a user ask for information about the various health conditions in the Northern Ireland Census data. There's about 12 health conditions related to things like sight loss and whether or not somebody needs a wheelchair. And this application lets a user ask questions like, give me information sight loss in health trusts. When the user clicks submit, the application works out what exactly is it that the user is looking for, what variables are relevant, and it performs a query to get the data and present it back to the user. So here we've ended up with a table for health trust by health condition blind. A more advanced query might be something along the lines of give me data on Alzheimer's in certain counties, so some counties Down, Armagh and Fermanagh, and give me the smallest numbers first. So again, once the user clicks submit, they end up with a table that's got a cross-tabulation of counties in Northern Ireland for the variable health condition with confusion and memory loss. We've only given information, they've only been provided with information for the tables, or for the counties have actually asked for, and the numbers are given in ascending order. And there's also a link to the actual data on the NISRA Census website, so they can get back to the original source of the data. So how does this actually work then under the hood? Whenever the user types data into the website, the application takes that request, takes that table description, and it sends that to an LLM. Along with this information from the user, we also send it information about the various health condition variables and the geographies that are relevant to the census. And we pass the LLM instructions that tells us, okay, well, we want you to identify which health condition variables are relevant to the query from the user, which geographies are relevant, along with some other information about how they want it formatted. And we tell LLM to return us that data in a particular format, a structured format. The health condition app then will take that structured data that's returned from the LLM, and it'll generate a query for the Cantabular API. A query sent to Cantabular, it performs a tabulation in real time, it applies statistical disclosure control techniques, and returns raw numbers to the health condition application. The application then does some formatting on the table, and it presents the tables that have been shown in the previous demo. The important thing about the approach I've taken here is that I've used the LLM in order to infer the intent of what the user is looking for. So it identifies the variables, the geographies, that kind of thing. But in terms of actually doing any manipulation on the data, I've kept that outside of the LLM, and I use more traditional software methods. And the reasoning behind that is from experimentation I did. So before I wrote any code, I played around with ChatGPT for a while to try and figure out what kind of things it was good at and what kind of things it more struggled with. So I was able to, one thing I found, I could give it metadata about the various health condition variables. So said there's about 12 variables in the data set. And if I give it all the metadata, like the name, label, description, I was then able to ask ChatGPT questions about those variables, and it could give me answers, identify the variables I was talking about. So for instance, if I asked it which variable relates to Alzheimer's, it was able to tell me that the correct variable was health condition for confusion and memory loss. And this is significant because Alzheimer's isn't actually mentioned anywhere within the metadata. Terms such as dementia and confusion are mentioned in the metadata, but not the actual term Alzheimer's. So ChatGPT is smart enough that it can associate Alzheimer's with dementia and then return the right variable. So this makes it much more powerful than, say, a text search that's just using words. So that gave me confidence that I'd be able to use ChatGPT to identify the kind of variables we're looking for in the application. Then I started experimenting with how good ChatGPT and other LLMs might be at manipulating numbers. So it started off quite promising. If I give it a list of a few numbers and I have to do basic calculations like calculate the mean of the numbers, then I was able to do that in a robust and reliable fashion. But when I started asking it to do somewhat more complicated operations, I started to see it struggle a little. So for instance, if I give it a list of 20 numbers in a list, and then I asked it to pick out every fourth number, so give me the fourth number, eighth number, and so on. In some cases, ChatGPT was able to do this reliably. And as well as giving me the numbers, it was able to tell me what method it was using in order to generate that list of numbers. But on other occasions, whenever I asked it the exact same questions, give it the exact same input, it could still tell me what it was trying to do, but it couldn't actually come up with the right list of numbers. And we really shouldn't be overly surprised at this. As Mike mentioned earlier on, the large language models use probabilistic models to predict what text should come next. They're not actually using mathematical methods in order to do the calculations on the data. So that doesn't necessarily mean that you shouldn't use LLMs to manipulate statistical information, but you need to be very careful if you're doing that. So from the work I've done over those few days, the main things I learned were that LLMs are a great way at identifying what a user wants, so identifying the intent in a user request. I also learned that if you're going to be using LLMs to manipulate statistical data, you need to be very careful with your engineering. And one of the other things I picked up on was that there's actually limits to how much data you can send to an LLM. So if I wanted to expand my application to handle all the variables in the census data set, then I'd probably need to use more sophisticated approaches. For instance, I could use the embeddings that Mike mentioned earlier on, and that Spencer, my colleague, actually used in his app, and he'll talk about that now.
Hi there. Right, thank you very much, Peter. I'm just going to share my screen here. Okay. Okay. Yeah. So I set out to create an AI assistant who can help people discover, explore, and download data from Cantabular. So what does that look like in terms of functionality? Basically, I wanted to allow the LLM to explore the Cantabular database and use the information it finds, so that it could answer questions like, what data is available? Do you have anything on how well educated people are? Can you give me data on people cross-tabulated with breathing problems and occupation? And with every response, I wanted to provide links to relevant sources of information so that the LLMs used, so that the user can double check answers or continue their journey on the website. So I'm now going to give a live demonstration of some of these capabilities using the Hackday prototypes created when I teamed up with Mike. Okay. Sorry, let me just do this. Okay, there we go. Sorry about that. Okay, so here we have the chat UI that Mike made on the Hackday. It's connected to the chat server that I made, and the chat server in turn is connected to both the OpenAI API and the NISRA Flexible Table Builder website. So now we can start a conversation to find out what data is available and find something we're interested in. So we can start by asking, what data do you have? So we get an answer here telling us that we have 2 data sets available. So let's find out more about one of the data sets. So I'm going to say I'd like figures from the people data set. Okay, so here it tells us a little bit about the people data set. It says, okay, these are some of the variables that are available. What would you like to do? So I'm going to say, I'm going to have a look for something specific. So I'm going to say I'm looking for problems with breathing. Okay, so it says here there's the health condition breathing variable, which has a couple of categories. So I'm going to want to see that data. So I'm going to say, show me that data table. Okay, cool. So the AI's gone off and it's got the data to provide the answer. It's shown us the data there, and it's, if you notice at the bottom, there's a data query page link. So that takes us to the data summary page on the, in this case, NISRA website, where people can check the accuracy and completeness, or go on to select further variables or download formats. And then finally, let's see if we can add another variable in. So if we ask it, can you break that down by sex 2? So the AI is now checking to see if there's a suitable variable it can use for that. And it's added sex into the query as well. So it's now got a query of health condition and sex. And again, the links at the bottom here show like to the metadata and to the query summary page, so people could go off of those things selected and find out more. So now basically, if we go back to the main presentation, we can look at the approach. So as I mentioned in the demo, Mike and I developed prototypes on the Hackday for the chat UI, web interface, and the chat server. The UI provides the message thread display and gives us a place to write our questions. The server handles the questions, interactions with the AI and the Cantabular database, then returns answers to the UI. The LLM has access to a number of different operations or tool calls that it can use to answer the questions. The application can iterate on those tool calls So if the LLM needs to use more than one to answer a question, it can. And the tool calls also make use of embedding vectors, as Peter mentioned earlier. And that allows us to expand the variable search capabilities. Looking now at the prompt that we provided to the LLM, we tell it that it's a data scientist and that it has access to a database. We give it some information about how data is organized in the database. And in the next set of instructions, we tell it to basically make good use of the tools available to it and to stay on track. So what conclusions can we draw from this work? I found that during development, knowing that you change something for the better is hard. So due to the non-deterministic responses from the LLM, the way it phrases answers to the same question can vary significantly. I found that response times from the user perspective can seem slow. And there's a lot happening in the background, such as multiple round trips to the LLM for tool calls. The user doesn't see any of that. They just see a spinning wheel whilst they're waiting for the final answer to come back. I learned that the LLM is surprisingly good at using available tools. It can make sensible choices about which to use. And found that the selection state is best managed by the server, not the LLM. So it's best to have tools like select dataset, add variable available to the LLM to use, rather than expect it to remember all those things along the way and specify them all in the query at the end. We also learned that we get problems when the LLM fails to associate parts of the user question to variables or categories. You might see things like the selections being incomplete, or the tool calls the LLM makes might not be appropriate, or might specify the wrong information if it determines the meaning of the question wrongly. So that's my presentation. I'd like to swap back over to Mike now. Thanks.
Thanks, Spencer, and thank you all guys for great presentations. So I'm just going to really quickly summarize some things that I thought were interesting from those, and then we'll move on to the questions that anyone in the audience has. So in the meantime, if you do have a question, feel free to find your way to the Q&A functionality and to start typing it. So summary was, well, I think Duncan was telling us that large language models are trained on natural language, and so it is best to talk to them in natural language rather than kind of sending them structured input. Spencer was telling us that understanding, because of the probabilistic nature, that evaluating the impacts of changes in approach or changes in your prompt can be very difficult. And this kind of comes back to what I was saying at the start about how engineering around LLMs can be very difficult in practice. Spencer was also saying that using things like OpenAI's tools, which are also maybe, there are similar things provided in software packages that you can use with LLMs that kind of validate the outputs from LLMs and make sure that if you're expecting structured data from them, that you get it in the right format, is very helpful if you're integrating the LLM into some other application. And finally, Peter told us that they're really good at identifying intent, so users' intent in the question, but to be careful if using them to manipulate data. And in fact, maybe for some use cases, it might be better to sort of leave the data handling to another part of your application. So finally, what are we doing next within our team with LLMs? We're going to carry on experimenting with this kind of chat-based interface to query data and sort of trying to find the best architecture for that. We think there's an opportunity to use embeddings to enhance the search results that we have within our product. And we'll definitely be continuing to use them for internal working practices. So as I said earlier, we already use them when we're coding. And we've started to use Google Workspace's Duet AI, although mostly so far for generating stupid backgrounds for Google Meet calls. So that's everything from us. There's a couple of links there if you want to find out more about Cantabular and see it in action.